Happy New Year, ladies and gentlemen. Welcome to trigonometry. So, first thing we're going to do is just a very basic review of the trig functions and some Pythagorean theorem problems. Maybe just talk a little bit about some fractions and simplifying some radicals. But overall, this is a real basic intro day. So the first thing, let's make sure we remember the trig ratios, the basic trig ratios, sine, cosine, and tangent. The sine of an angle, and you need to make sure you always have an argument in there. Don't just ever write sine equals something. You need to say the sine of something. So the sine of angle x, we're talking about the ratio between two sides. You might remember SOHCAHTOA, SOHCAHTOA, if that helps you. Okay. So is OH. Sine is opposite hypotenuse. So this is the opposite side over the hypotenuse. The sine of an angle is the ratio between the side that is opposite that angle and the hypotenuse. And remember, the hypotenuse is always the longest side. Cosine, CAH. Cosine is adjacent divided by hypotenuse. So the adjacent side, if I'm using, let's say this is my angle theta. Let me get that so you can see it. If I call this angle theta, opposite theta is x, and adjacent theta would be radical 3 over 2. And then the hypotenuse is 1 for both of those. And now for tangent, tangent is TOA, opposite over adjacent. So those are our three basic trig functions, but I'm also going to remind you that we have reciprocal functions that we will use quite a bit. And if I say the reciprocal of sine of x, 1 divided by the sine of x, that is the cosecant of x. Cosecant. And I know you want the cosecant to be the reciprocal of cosine, but it ain't. So just remember that. The reciprocal of sine, or you could also say the hypotenuse divided by opposite, if you flip it, that's the cosecant. 1 divided by the cosine, the reciprocal of cosine, or hypotenuse over adjacent, is called the secant of x. It's the reciprocal of cosine. And the last one, cotangent, is the reciprocal of tangent. So you could write that as 1 divided by tangent, or adjacent over opposite. So that's the 6 basic trig functions we will use, all of those quite regularly. Well, the 3 basic and the reciprocals. So now let's do a Pythagorean theorem problem. It says, use Pythagorean theorem to find x exactly. Well, remember the Pythagorean theorem, a squared plus b squared equals c squared. So x squared plus radical 3 over 2 squared equals 1 squared. So to do this, x squared is going to stay the same. When you square a fraction, you're going to multiply the top times itself and the bottom times itself. So the radical 3 times radical 3 is radical 9, which is just 3. When you square a square root, you just get the radicand, the part underneath. 2 squared is 4, and 1 squared is 1. Now, you want to get x squared by itself. Since there's no x to the first, we can just solve like an equation. But you need to remember, this is 1 whole. This is 4/4. If it helps you to think of this as 4/4, that's what 1 is. If you subtract 3/4, now we have 1/4. And the last thing I'm going to do is square root both sides. And you need to remember that when you square root, there's always a plus or minus. There's 2 answers. And depending on the context, you might need to say which one is appropriate. Now, when you square a fraction, square root of fraction, same thing. The square root of the top, square root of 1 is 1, and the square root of 4 is 2. So x is plus or minus 1/2. Now, in this context, I'd say it's probably positive 1/2. I didn't tell you that we're in a quadrant or anything, so it probably makes the most sense to say it's positive. But you're going to see what I mean here in a second when you're going to know that the answer is positive or negative. So let's look at that. First thing, just a basic unit circle review. What is the unit circle? When I talk about the unit circle, just imagine, I could do better. That's pretty good. All right, that's a pretty decent circle. All right, so that is my circle, and we call it the unit circle because the radius of this circle is 1 unit. 1 unit makes the unit circle. So what you need to realize is that means that all of these radii, any radius that I draw, is length 1. So that yellow segment is length 1. That's length 1. That's length 1. Wherever I'm at, it's length 1. Even if it's on the quadrant angle, that's length 1. This is called the unit circle because the hypotenuse of any triangle that you draw is 1. And you're like, well, I don't see a triangle. I can put any point on the outside of this circle and then construct a triangle to describe that as an x-y pair. Think about it. You drop an altitude, you have an x coordinate, and you have a y coordinate. We know the hypotenuse is 1. So when I say what's the equation of a circle with radius 1, we're doing Pythagorean theorem. X squared plus y squared equals 1. The equation of a circle is the Pythagorean theorem here. X squared plus y squared equals 1 squared. Now, you might have learned it with a translation in there, something like this. But if I'm asking the circle to be centered at 0, 0, then h and k would be 0, 0. X minus 0 is x, y minus 0 is 0, and the radius is 1, so you end up getting this equation. But what you just need to keep track of is that every radius that you draw is 1, and then you can break this up into a triangle with the xy pair. So using that idea, you can tell me that points are on the unit circle, because if they are, then they have to satisfy the Pythagorean theorem. So if I imagine drawing this point, and I don't know, it doesn't really matter if it's to scale or anything, but I know that they're both positive. So if x and y are positive, I'm just imagining drawing a triangle and saying, all right, the x coordinate is radical 3 over 3. The y coordinate is radical 6 over 3. If it's on the unit circle, then that means the hypotenuse should be 1. So the question is basically, prove to me that the hypotenuse is 1. You might also see these written as verify that the point is on the unit circle. This is an algebraic proof. You're trying to just show me that it's a true statement. So radical 3 over 3 squared plus radical 6 over 3 squared. Show me that that equals 1. So when you do that, you square the top. Radical 3 times radical 3 is 3. 3 squared is 9. Radical 6 squared is 6. 3 squared is still 9. And then if you look, 3/9 plus 6/9 is 9/9, which is 1. So this point is on the unit circle. Imagine that there's the circle here. This point's on the unit circle, and it's x, y. If you do Pythagorean theorem, we'll give you a hypotenuse of 1. So we know it's on the unit circle. It's an algebraic proof. You're showing me these steps. That's what the question is asking you to do. Now the next one says we have a point on the unit circle, and it's located in quadrant 4. I'm just going to tell you now that if I ever give you a quadrant that is not like ancillary information, that is something that matters. It matters every time. So make sure you're paying attention to what that's telling you. That's telling you where we are in our quadrants. So if we're in quadrant 4, let me just remind you, we've got quadrant 1, quadrant 2, quadrant 3, and then quadrant 1 less than 5, IV, is quadrant 4. So down here, this is quadrant 4. So we are in quadrant 4. I'm going to just sketch a triangle, which if you don't like sketching triangles, then you're in the wrong class. This is triangleometry, trigonometry, folks. Radical 3 over 2, and then a y. And if it's on the unit circle, they're telling me, hey, the hypotenuse is 1. So you don't need to prove to me. We're telling you the hypotenuse is 1. Now, I don't know why, but the fact that I'm in quadrant 4 tells me something about y. And that is, if I have to go to the right, I know x is positive. But if I have to go below the x-axis, then I know y is negative. So I know my answer is going to be a negative number. Now, this is actually the same algebra that we did just a couple steps ago. It's the same problem, which you're going to see a lot of the same numbers when we do this because we have a finite set of answers on the unit circle. 1 minus 3/4 is again 1/4. And when you square root, you get y equals plus or minus 1/2. So this is the same, as up here. Okay, it's the same work. But now that we know we're in quadrant 4, there's not a debate about it. It's not plus or minus 1/2. The only answer is negative 1/2. It is in the 4th quadrant, so the answer is negative. And that's something that is going to be, it's going to happen all semester long. So just make sure you're paying very close attention to which quadrant you're in and whether x and y are positive or negative, just right out the gate. All right, now you have some practice problems here, basically some verify problems and then some find the missing component problems. I'm going to leave those for you, but there are a couple arithmetic things in here that I want to do. So I'm going to do number 4 and I'm going to do number 9 with you, and then I'll let you guys do the rest. And remember, this is on Schoology. You can check all your answers. So if I say show that the point's on the unit circle, I'm doing the same thing. I'm going to prove using the Pythagorean theorem that the hypotenuse is 1. Now, a couple things to keep in mind. When you square a negative, it squares out. A negative times itself is going to be positive. So you can kind of ignore that. You're just like, oh, look, it's 5 squared. 5 squared is 25. 7 squared is 49. I know 7 squared is 49 down here, but squaring that is a little bit trickier. 2 radical 6 times 2 radical 6. This is some radical work which we did in first semester, but a little refresher here. 2 radical 6 times 2 radical 6. You're going to multiply the 2 and the 2. The outside terms are going to get multiplied. 2 times 2 is 4. And then radical 6 times radical 6, that part of it is going to also get multiplied. Radical 6 times radical 6 is 6. So this ends up being 4 times 6, which is 24. So when you square that, make sure you multiply the outside part, and then you multiply the radical times itself, and it'll end up just being this squared times this squared. What do we got here? 25 plus 24, that's 49 over 49, and the goal was to prove that it equals 1. 49 over 49 is 1, so that does it. Just make sure you pay very close attention to squaring this. That's going to be something we do all semester. And the last one, find the missing component. So here for number 9, we're in quadrant 2. Remember, quadrant 2 is off to the left. So x is negative and y is positive. That means I know my answer is going to be negative. So y is 1/3. I'm going to look for x, and I know that I'm on the unit circle. I know I'm on the unit circle because it tells me we're on the unit circle. So we're describing this point P, which is on the unit circle. And I'm asked to find x, so I'll do 1/3 squared plus x squared equals 1. And this is the quantity 1/3 squared. Make sure you're being careful there. 1/3 times 1/3 is 1/9. This is 9/9. Remember, 1 whole is 9/9. 9 minus 1 is 8/9. And now when I square root the top and the bottom, okay, so I think, well, it's plus or minus. The square root of the top is radical 8. The square root of 9. The square root of 9 is 3. But you have to look at this. This is not going to get you credit, folks. Radical 8 is not simplified. So you need to remember, make a factor tree, 2 times 2 times 2, and say, oh, okay, that's 2 radical 2. So since we're in quadrant 2, we know x is negative. It's negative 2 radical 2 over 3. So when you simplify radical 8, you get 2 radical 2, and you need to do that 100% of the time you're given a radical. So finish up the rest of those problems. I'm going to throw another unit circle video up for you where we actually start to introduce some of the unit circle terminal points. So make sure you take a look at that for your RLE day. Get these practice problems done. And if you can do all that, you're in good shape so far. So make sure you just hit that like and subscribe button.